Hello, today's lesson is going to cover lesson 3.4. These next two lessons will just be algebra review lessons on slope and equations of lines that run parallel and perpendicular to specific situations. So we're going to review a little bit of algebra and some of those formulas. Please make sure to kind of follow the note sheet so you have some examples to follow as you're working. Go ahead and pull up our notes so we can take a look at them. All right, so first of all, in lesson 3.4, we want to be able to calculate slope using parallel and perpendicular lines as a reference as we move through to some more specific applications. But what we do want to do is kind of look at exactly how slope affects a line on a graph. So first of all, if we're looking at slope or the slant of a line, we're always measuring slope as we would read the graph from left to right. So if I were starting in this location here and following this horizontal line, we should see that as we're moving to the right, there is no slant, or no slope to this line. So this would be considered a zero slope, as we're moving horizontally. Now, once we get to this point, on this little graph, now as I move to the right on my graph, this line is continually moving upward, or it's slanted upward. It's moving in a positive direction on our graph, so this is going to be a positive slope. From this point, that changes, and this follows a decreasing pattern, or now the line is moving downward as I move to the right. So this one is going to be a negative slope. And then when I get to this point, we should see we have this vertical segment. What you need to keep in mind is slope is always measured as you move to the right. Well, if we were at this point on this vertical line and we move to the right, we're no longer on it. There's no way to measure the slope. So anytime you have a vertical segment, this is going to have no slope, or we describe it as being undefined because it's not measurable, There can't be any slope to our vertical line. Now keep in mind when we analyze slope on the graph, we look at it two different ways. We can say that slope is the rise over run. So how far is the line moving up or down as we move to the right, on our graph? Again, if this number comes out positive, our line would be going upward. If that value comes out negative, that line would be going downward. If we actually have coordinates on our graph that we are using, our slope formula was y2 minus y1 over x2 minus x1. Should see how that correlates to the formula itself. Rise on a graph is moving up and down, so is a y-axis. So you should be using your y coordinates in the numerator. Your run is being measured as you move to the right. Therefore that's our horizontal axis. We should be using our x coordinates in that denominator. How that pertains to us geometrically in chapter 3, involving parallel and perpendicular lines, is we want to know exactly how that slope is going to work. We do know that parallel lines do not intersect. Therefore, they have to have that exact same slant or slope. So when we look at parallel lines, it has to have an equal slope between the two lines. However, if lines are perpendicular, we absolutely need them to intersect, and we need them to intersect at exactly 90 degrees. To be able to do that, okay, we are going to have lines that are opposite in sign, one being positive, one being negative, for instance, okay, and reciprocal values on that rise over run so that they do actually cross at exactly 90 degrees. Okay, so perpendicular slopes will be opposite reciprocals. So let's go ahead and kind of take a look at what this looks like when we look at just a few examples here on our slope. So we want to find the slope of the line that runs parallel to the line through these given points. So if it's running parallel, okay, I'm going to pick out an equal slope to the line containing these two. So whatever the slope is for this one, our parallel line will also have to have that exact same slope. So my slope will be, and again, we want to subtract those y coordinates. So 6 minus 1 over, and then the difference of my x coordinates, so 0 minus 2. Be very careful with signs as you kind of work with these so you don't mess up, okay, the positive or negative value of that slope. So 6 minus 1 gives us a value of 5. 0 minus 2 is negative 2. So we get a slope here of negative 5/2. So this line would be moving downward, and it would move down 5 units for every 2 that we move to the right. Okay, so that slope would have to stay exactly the same for my line parallel. However, when I want to create a line perpendicular to a line, we're going to need the opposite reciprocal for the slope. So I'd want to calculate what this slope is going to be on that given line first. So we would subtract our y coordinates, so 2 minus negative 6 over 5 minus 7. So we get 8 over negative 2, which reduces to negative 4. Now, if the slope of the given line is negative 4, the slope that will run perpendicular will have to have that opposite sign. So if this one was negative, ours will be positive, and the reciprocal of 4 is going to be 1/4. So the line I want to create running perpendicular will have to move up 1 unit for every 4 we move to the right, okay, or have a slope of positive 1/4. Now, if we look at lines either being parallel, perpendicular, or oblique, okay, meaning it doesn't fit into either one of those, they're just going to be intersecting lines, if you see that. We'd want to actually calculate what their slopes are because we can compare the slope or the slant of the line to tell what type of lines we have. So if we look at the slope of line 1, I could just label that as M1. We would plug into our slope formula, so 2 minus 3 over 5 minus 0. We get a value here of negative 1 over 5, or a slope of negative 1/5. Okay, if I look at finding the slope of this second line that was given, subtract my y coordinates, so 7 minus 2, over, and then my x coordinates, 2 minus 1. This would give me a value of 5 over 1. So if I were to compare these, they do have opposite signs. One is negative, one is positive. And then they are reciprocals of each other, 1/5 and 5 over 1. So they are opposite reciprocals. We would consider these to be perpendicular. Okay, so if they're parallel, they would be exactly the same. Perpendicular have to be opposite reciprocals, exactly. Okay, anything else will create intersecting lines. All right, there's a little review, okay, on your slope. and we will just use that to kind of answer some questions about lesson 3-4. So complete the Google form, then assigned in this week.